Okay, review lesson number 3 is our actual lesson number 3. It says right here at the top of the page, we're going to do the evens together, and then the odds will be your practice. So we're going to be working over here on the right side today. This is just kind of putting together what lessons 1 and 2 we're talking about. Right here, we're trying to simplify, which means we're going to combine. We want to take all of these and shove it together. When we multiply with like bases, multiply exponents with like bases, we add the exponents together. So we have a base of y, and it's simply 7 plus 3 plus 2. So it's 12. If you wanted to like really understand, right, this would be, I have 7 y's, and then I'm multiplying that by 3 y's, and I'm multiplying that by 2 y's. And so go and you count up how many y's do you have. You got 12. Number 4. Okay. I'm still multiplying with like bases. This time my base is x. Okay, remember, the base is the thing attached to the exponent. That is what the exponent is doing the raising of. And we're gonna add these together. I see -4, -4, +4, add it all together. I have -4. Now, that's not good enough. We can't have negative exponents. Remember, that's not allowed. So how do we make something positive when it comes to an exponent? Well, it changes sides. If it's in the top, it goes to the bottom and just becomes positive. Or if the negative's in the bottom, it's gonna go to the top and it's gonna become positive. So how do I make this go to the bottom? Well, even with exponents, you know, x is a whole number or something, it's a constant. It has a 1 underneath it. So we're gonna make it go underneath. And it's gonna become positive. In its place, a placeholder of 1. Okay. But why? Why does this rule work? Okay, let's take a look at this. I have x to the -4 times x to the -4 times x to the 4. Well, I can't have negative exponents, so this is going to need to go to the bottom. Just like that, this one's going to transform into 1 over x to the 4, and this one will do the same thing. And that last one is positive, it can stay in the top. Now we're going to multiply everything straight across, and if I want to see this exploded outwards like we did that one, I have 4 x's on the top, and I have 8 on the bottom. Okay. Here now, we're going to cancel 1 on top with 1 on the bottom. Okay? Get rid of you. And what am I left with? I'm left with no x's on the top, so I have the placeholder of 1, and then 4 on the bottom. So that makes sense. Okay. 6. When I have an exponent on the outside of a set of parentheses, it's called the power rule. I need to bring that in. And how I bring it in is a lot like distributing. I give it to every item inside. Here's how we do that. Real numbers will get raised to it. So this is going to end up looking like -2 cubed. And then I have b, it was -2, but when I bring stuff in with exponents, I multiply them. So it's going to be 3 times -2, which is -6. And then c, 3 times 3 is 9. Okay. So now we need to identify this number. This is the last part of the problem. B and C are done. This, well, B's not done, but for right now it is. I'm gonna figure out this. When I cube something, I'm taking it, exactly it, and I'm multiplying it by itself 3 times. So this turns into -2 times -2 times -2. 2 times 2 times 2 is 8. Negative times negative is positive, times another negative, we'll change it back to negative. And then put it all together. Negative 8, B negative 6, C 9. I would be done, but there should be a red flag right here going off. You can't have negative exponents. So B, your negative 6 can't happen. Negative 8 can absolutely stay in the top though. We can have negative numbers, right? We can have negative temperatures. Negative numbers exist and have existed forever since you've been doing math. But negative exponents can't. So negative 8 will stay in the top. It's gonna hang out with C9 because that's also available to be in the top. But this needs to go to the bottom and it needs to become positive. That is my final answer there. All right, so to recap, when I bring things in, real numbers will get raised to that exponent on the outside, but the ones with already attached to variables, these get multiplied. So raise whole numbers, multiply variables. Okay, 8. I'm gonna ignore this in the front, just ignore it. I'm gonna deal with this right now. This is my biggest thing I need to worry about. So just like last time, I'm gonna take it and I'm gonna give that 3 to everything on the inside. All right, this is going to look like 2 cubed. And then Z, I'm supposed to multiply this in, but there's nothing there right now. Nothing that I can see at least. There is an invisible 1 there though. So it's gonna be 3 times 1, which is 3. Okay. Now, we just did 2 cubed, but that looks like 2 times 2 times 2. When positives, we don't have to worry about the sign. Okay, so that's 8. This is just normal. So I bring that up, I say, okay, if I distribute this cube, that's what it turns into. But now I need to remember, I ignored this thing in the front. I gotta put it back. So maybe I put this back in its parenthesis, and I write 8u in front of it. Now, when things touch, they multiply. That 8u is touching the 8z cubed. So it is multiplying. You're gonna multiply real with real and like with like. So this is a real 8, this is a real 8. 8 times 8 gives you 64. And I can't multiply a u and a z cubed, right? Like I can't multiply an a with a b, it just becomes ab. So this is going to become u z3. Just stick them together. All right, here we've got a division problem. So we're gonna take this and we're gonna separate it piece by piece. Ends with n. Okay, so let's worry about the real number first. I see a negative 6 on top and 18 on the bottom. Don't get confused with exponent rules, okay? Negative 6 over 18 reduces like normal. If I gave this problem to you like 3 years ago, you would be able to put this in your calculator, or you would just know that this reduces to 1 over 3 because 6 goes into 18 3 times, and then you would follow up and make it negative. That hasn't changed, and it won't change here, okay? Don't freak out, don't put like 12 in the bottom or something like that, you know, because you think things get different, because they don't. All right. Now we're going to talk about the ends. I see 5 on top and 1 on the bottom. So I'm going to ask which n has more ends, top or bottom? And you would say the top. I would ask how many more does the top have than the bottom? And you would say 4, because there's an invisible 1 there. I'll do the same thing with the x's. I have 3 on top, 7 on the bottom. Which x has more x, top or bottom? You say bottom, and you say there are 4 more. Okay, so this is my answer. If you wanted to explode this thing out, you would make it look like this. -6/18. Okay. And you would have 5 ends. 1, 2, 3, 4, 5 on the top, 1 on the bottom, and then you would have your x's. You'd have 3 on top and 7. Okay. Again, you don't need to do this, but this is the visual of what's happening, why this shortcut works, which has more top or bottom. Okay. And now you would go canceling. You would say that I'm gonna get rid of this guy and that one, and now I can't eliminate any more ends. So looks like I'm left with 1, 2, 3, 4 on the top. And I would go canceling x's. And I can't cancel any more x's, and you're left with 1, 2, 3, 4 on the bottom. And then this, of course, will reduce just like that. So there we go. Okay, next page, number 12. We're gonna bring in that exponent of 2, but we're gonna do it to everything, not just the top, and not just the whole numbers, but everything. So this might look a little messy by the time I'm done giving arrows to stuff. Okay, kind of looks like Dr. Octopus. I've been watching a lot of Spider-Man. So we're gonna make sense of this. I'm gonna get rid of the parentheses because I don't need it anymore. It was just holding that 2 at bay. So that 2 has been let in. Real numbers get raised. So this is gonna be 2 squared in the numerator. This is gonna be 3 squared in the denominator. And my exponents, when I'm raising exponents to other exponents, get multiplied. So it's gonna be r 2 times 2, 4. T 3 times 2, 6. Z 12. Okay. All right. Now the variables are done. I don't see any negatives, so no one needs to go like flip and change signs. I just need to make sense of these because 2 squared is a real number. It's 4, and if my goal is to simplify, I need to present what the number actually is. 3 squared is a real number. It's 9. And there we go. All right. This one, love it. Love this one. This one freaks people out. Okay. Let's maybe look at it one at a time. Ignore this second bubble. Let's work on this smaller one over here first. I need to bring in the outside exponent and give it to everything on the inside. When this happens, I multiply them. So this is gonna look like m 4 times 4, 16, and 6 times 4, 24. Okay, so that is taken care of. This is as simplified as it gets right here. So this part's done. Over here now, I'm gonna do the same thing. I'm gonna take the 6 and I'm gonna give it to the 3 and the 2 and the 5. And now this one over here will look like m 3 times 6, so 18, n 2 times 6, so 12, p 30. Okay, we multiply those. All right. So simplified over here, everything is good, except it's not as simple as it can be because I should only have one instance of m. I should only have one thing of n. I need to combine this. And if I look back up, even though the 4 is kind of getting in the way, those parentheses, they're touching. So they're multiplying, which means it can look like this. Now, if our rule says when we multiply with like bases, we really add them, right? That's what we did at the beginning. That was like number 1 and number 2. We added those things together. So we're gonna add them, we're gonna combine. M, 16 and 18 more give me, I think, 34. N, 24 and 12 make 36. And then P doesn't have anyone it could combine with, sorry, P. There we go. So it looks scary, but like, not that bad. It's kind of satisfying to put that together. I don't know, maybe I'm just a nerd. Okay, here, 16. Okay. So usually, right, we would start, so we have an exponent on the outside, and we would bring it in, and we would give it to everything, and then we'd multiply, and then we'd do stuff and with things. But this one's a bit different because that exponent's negative. Even on the outside, you can't have negative exponents. So maybe it's simpler for everyone just to flip it right now. This negative, right, it would need to go to the bottom and become positive. Well, treat this negative exponent, it makes the problem look like an hourglass. We're gonna tip it on its head. So I'm gonna rewrite this with negative x squared y 5 on the top, and then 2x cubed y squared on the bottom. And now that has gotten rid of the negative exponent. That is going to make this so much easier. So let's go ahead and do that right now. Now we're good to take this and give it to everything. Okay. All right, let's see here. I have this first thing. Uh-oh. Slight problem. I missed something. Maybe you can spot it. There's a number here. It's not shown, but the number that's hidden in front of the x squared, it's actually a 1. So really, this -2 is also going to that -1. So let's see here. I have -1 being squared. And then I have x squared, and we know when we bring stuff in like that, right? Exponent already have an exponent. We multiply, so that's gonna be 4. Y to the 10. Okay, that's my numerator. Then I'm gonna have a 2. And real numbers get risen. So that's gonna be 2 squared as well. X has a 3, 3 times 2 is 6. Y has a 2, y times 2 is 4. Okay. So now I need to figure out what this is. -1 squared is really saying I have -1 and I'm multiplying it twice by itself. -1 times -1, that makes +1. 2 squared is 2 times 2, that's 4. Okay, so the real numbers are done. Let's work only on the x's. Which one has more, top or bottom? You say bottom, and you say it has 2 more. Y's, looks like top has more by 6. Okay, I'm not gonna do the expand rule every time. I want to get used to this shortcut. That one was tricky. I almost forgot that -1. That would have been a disaster. Okay, only a couple more. All right, I got this one. Let's take care of all of the outside parentheses first, and let's learn the lesson that we did last time. And remember that there is, in fact, a -1 in front of this, if that matters for me, and a -1 in front here and a 1 in front here. Maybe it matters, maybe it doesn't. Let's see. I'm gonna rewrite everything. I just wanna get rid of these exponents on the outside right now. I want that to go away. So -20. And then that is gonna be v, -v cubed. Okay, so maybe it makes sense if I read it like this. -v times -v times -v. Okay, let's see. Negative times negative make positive. Positive times negative makes negative. Okay, so we're gonna stay negative. And how many v's? 1, 2, 3. is 5. I like that. Okay, this one here is negative v squared. So I don't have this third one, it's just negative v times negative v. That's going to be positive v squared. And then this one, this exponent's already on the inside, so I don't have to do all of this stuff to the m. Only when it's on the outside do I have to do that. So here is negative m to the 4. Okay, we can start to simplify this. It's coming together. Let's combine everything across the top right now. I have a negative here and a negative here. That's going to make my numerator be positive. I see a 20. I see 2 m's, and I see 1 v and 3 more for a total of 4 v's on the top. In my denominator, I see a positive, a negative. So my denominator will be negative. I see a 5. I see 4 m's, and I see 2 v's. Okay. All right, we are going to simplify this now. We're going to take it like with like. (20) divided by 5, hopefully we know that that's 4. It's going to be negative 4 though. And if you want, you can put that 1 in the denominator, it doesn't matter. And truly, I don't care where the negative sign goes either. It can go on the top, it can go on the bottom. Doesn't matter to me, as long as it's there. I got 2 more m's in the bottom. And I have 2 more v's in the top. Isn't this stuff fun? You start with that and you're like, ah, and all that work just to get that. Isn't that satisfying? No, it's not. It's not satisfying. It is fun though, it is. Okay, now let's combine our like terms here and finish this up. I have normal w's. I don't see any other things with normal w's. I have w squareds. Over here I have some w squareds. I have 4. Okay, we're going to combine like terms, but we're going to remember that this negative is happening. So I'm really taking this and I'm subtracting this stuff. 6w is the only kind of w. Negative 11w squareds minus 7w squareds more. Okay. And this is the only kind of constant. All right, so now this is technically correct. Everything's combined, everything's good, except we can write it better in algebra because we want to have it to where the highest exponent is first, and then lesser exponents follow, and then ultimately I don't have any exponents my last term. What do I mean by that? I see where's the highest exponent? This guy, exponent of 2. He comes first. I'm gendering this term. I'm going to continue to do it. This one comes second. Let's make it a sheet. Okay, this is 2 exponents. I have an invisible 1 there, so 1 exponent. If you wanted to write that. Okay, he was he, she. No, this one hasn't figured it out yet. So that one goes at the end of the line. There we go. All right. Both of these are technically saying the same thing. This is just better, like algebraically. And I think this is our last one. Cool. All right, we are multiplying. So I am going to distribute this, okay? Remember, these problems are different because this one's touching that bubble, it's multiplying. This one's not touching and has an operation in the middle. All right, I need to give an x to everything. I'm gonna write that. X times x squared is x cubed. X times this term. Okay, just combine. You have an x already exists, okay? Slap another one on there. And then x times this, well, it doesn't have an x, so it's gonna get 1. Okay. Really all we did is give everything in here 1 more x. Now let's give a y to everything too. All right, and this is where I think the column method really works. You can write it in one big string if that works for you, cool. But like, I like the column for this reason. I'm gonna give a y to x squared. Where do I have x squared? Is it here, here, or here? It's here. So I'm gonna do plus 1 x squared y. Because the y goes with the x squared, that makes x squared y. And now it lines up nicely. I'm gonna give a y to this one. So I'm gonna end up with a y squared. Y squared is right here. And thankfully it already has an x. So minus 3 xy squared. And now for the last one, this y will come over here, creating a y cubed, and I don't have any y cubes, so that's why it goes at the end like that. Okay, with this method, we're gonna put it all together column style. I see x squared is the only kind of x squared, or sorry, x cubed. It's the only kind of x cubed, so it's coming down. Ignore the exponents. You have -3, you have +1, which means you have -2, and then the exponents come along with it. Ignore all this stuff. You have +2 minus 3, that's -1, and then the exponents will just go along with it. And then this is the only kind of that. All set. Isn't this stuff good? This stuff is fun.